Welcome back, everyone. Today we're going to discuss about properties of exponents. I would like to start off by giving you the parts of our exponential notation. So in this case, you have the number in the front as your coefficient. This is your base, and this is your exponent. The first property that we will discuss is the product property. The product property states that if your bases are the same, then you must copy the base and add the exponents. Let's take a look at this example. 2x squared times x cubed times negative 5x to the fourth. What you're going to do is you're going to tackle all the coefficients first, and this is going to be 2 times 1 times negative 5, which is going to be negative 10. And then you're going to go to your x's. In this case, since the bases are the same, which the x's are the same, you're going to copy the x's, and then you're going to add the exponent. So that's going to be 2 plus 3 is 5 plus 4 is 9. Your answer therefore is negative 10x to the ninth. The next property is the power property, and it states that if there is a power inside the parentheses and a power outside the parentheses, you're going to copy the base and you will multiply those powers. So for our example, x squared inside the parentheses raised to the power of 5 is going to be equal to x to the 10th. Next property is the product of a power property. The product of power property indicates that if there are two factors inside the parentheses, you're going to raise each factor to that power that is outside, which will be a to the n times b to the n. Example, 2x inside the parentheses raised to the power of 3 will be equal to 2 to the third times x to the third, which is equal to 8x to the third. So I also want to show this to you in another way, which is by the expansion method. So if we're going to expand 2x raised to the power of 3, it means that you will multiply 2x times 2x times 2x. 2 times 2 is 4, 4 times 2 is 8. And x times x is x to the third according to our product property, which is this is a power of 1, power of 1, power of 1. Copy the base, add the exponent. So that's going to be 1 plus 1 plus 1 is 3. Final answer, therefore, is 8x cubed. Our next property is the quotient property, which indicates that if the bases are the same and you are dividing them, you're going to copy their base and you will subtract their exponents. This has a restriction that a or the base cannot be equal to 0. Example, 10x cubed over 5x squared is equal to 2x to the power of 1. So real quickly, let me explain this once again. If you have coefficients, you're going to treat the coefficients the same way. So this is 10 over 5, which is a 2, and this is going to be x are the same bases. So you're going to copy the base, and this is going to be 3 minus 2, which will be a 1 here. There's a 1 there. I don't have to put the 1. It's understood that there is a 1 there. I would like to give a second example in order for me to use as a springboard to the next property, which is the properties of negative exponents. So let's take a look at this example. Notice that, well, I incorporated two things here. First of all, I had placed negative on the coefficient, and then I want you to focus on the exponent of your x's. So again, the first step is to tackle the coefficients. So that's going to be 10 divided by negative 5, which is going to become negative 2. And then we're going to apply the quotient property on your x's, which copy the x, and you're going to have 2 minus 3, which will be x to the power of negative 1. I just want to reiterate some important details. So first of all, I said here that there is a 1 that's understood to be there and I don't have to write. However, if it's a negative 1, you will have to write it and you will have to indicate that that's a power of negative 1. Now, this is not permitted, which we'll now tackle on the next property, which is the properties of negative exponents. There is a way on how we can make this into a positive. So once again, this is your answer, but not permitted as a power of negative number. And so we're going to do this. Copy the coefficient and move that x to the negative 1 down below on the denominator in order for the exponent to turn to a positive. So once again, if it's in the numerator, you're going to move it to the denominator in order for the exponent to change its sign. However, the negative 2 is not going to move because the negative there is not its exponent. The negative there is the sign of the coefficient, and the exponent of negative 2 is really a 1. It's a positive 1. So you're not moving it. You're going to let it stay there, and what you're going to move is the x with a negative exponent. So once again, you're only going to move it either numerator or denominator whenever the exponent is negative. Final answer is negative 2 over x. The next property is the property of the negative exponents. So if a is raised to a power of negative number, what you're going to do is you're going to move it to the denominator in order for it to become positive. However, if the negative is found as an exponent of a denominator, you will have to move it to the numerator in order for it to become positive. Now let's have some examples. X to the negative 10 is equal to 1 over x to the positive 10. Example number 2. 2x to the negative 3 is equal to 2 over x to the power of 3. Let me just explain it to you real quick. Once again, the power of the 2 here is a positive 1. So you're not moving it to the denominator. This is the only part that's going to go to the denominator. Example number 3, 5 over x to the power of negative 2. So again, that has a power of negative 2, and we'll have to move it to the numerator in order for the negative to become positive, which will be equal to 5x squared. Now, little things that I would like to emphasize. First of all, there is a 1 in the front. Okay, so if you move this up to the numerator, there is really going to be a denominator right here, which is over 1. I had put that in order to emphasize that this is the numerator and this is the denominator. So this is coming from the denominator, moving to the numerator, and this will have a 1 there. But of course, whenever we write this, we don't have to put over 1. Final answer, therefore, is 5x squared. The next property is the zero exponent property, which is any number raised to a zero power is equal to 1, provided that the base is not equal to 0. So I'd like to use the example 12 over 12. You know every number that is divided by itself is equal to 1. And how is that applied to the power of 0? So 12 has an exponent of 1 over 12, which has an exponent of 1. And then I'm going to use the quotient property, which is that if the bases are the same, I'm going to copy the base and subtract their exponents, which is going to be 12 to the power of 1 minus 1, which is 12 to the 0, which will go back to equals 1 right there. Example number 2, 5 squared over 5 squared. You know that 5 squared is 25, and that's 25 over 25, which is equal to 1. But let us apply the quotient property. Copy the base, which is 5, subtract our exponent, which is 2 minus 2, which is 5 to the 0, which is a 1. All right, so in the future, when you see an example that looks like this and it's all raised to the power of 0, please know that that is just equal to a 1. The next property is the quotient to a power property, which is that if you have a fraction inside the parentheses and there's a power outside, what you're going to do is you're going to distribute this power to both the numerator and the denominator, making it become this for as long as b is not equal to 0. Example, x over 5 all in parentheses cube would be x cubed over 5 cubed equals x cubed over 125, because 5 times 5 times 5 is 125. 5 times 5 is 25. 25 times 5 is 125. Our last and final property is the quotient to a negative exponent, which indicates that if you have a fraction inside the parentheses raised to a negative exponent, you're going to have to flip the numerator and the denominator so that the exponent becomes positive. This is better shown with an example, so let's have an example. x over 2, all in parentheses, raised to a power of negative 4. So we have learned from the quotient to a power property that whenever there's a fraction inside the parentheses and there's a power outside, that you're going to distribute this power to both the numerator and the denominator, like this. But we also learned that from the properties of negative exponents that in order for us to change the negative exponent into positive, if it's in the denominator, we're going to move it to the numerator. And if it's in the numerator, we're going to move it to the denominator like such. And so therefore working backwards and extracting this exponent and putting it outside the parentheses, it's going to look like this other one that we have there. So if we're going to take a look at this, so this is our example for this property. And notice that the numerator and the denominator, in order for us to make it positive, had flipped right here. And this is the whole work and the proof. And so this ends our lecture on the properties of exponents.